All right, sports fans, we are back. We want to teach you today, or review today, the skill of counting atoms in a formula. The worksheet looks like this. If you haven't got one of these, make sure you come and ask for it. Number of atoms in a formula. So this is a useful skill because when we look at formulas, you got to be able to pick out the individual atoms or elements from the periodic table that are in there. So let's start off. The very first one on here is a chemical formula that we see all the time, NaCl. And so how do we tackle this? On the periodic table, remember that anytime we're starting with a new element, it always begins with a capital letter. So up here, the capital N lets us know we've got an element, and the lowercase letter right next to it means it's part of that first element. It's not until we get to the capital C that we get to element number 2, and the lowercase l belongs to it. So in this basic one, when we count atoms, look for capital letters. Here, Na is sodium, and since there are no numbers next to it, we automatically have one of those. And chlorine, since there are no numbers next to it, we automatically have one of those. This is a total of 2 atoms that make up sodium chloride, or NaCl. Okay? Now, there's got to be more to it. There is, people. Take a look at the next one on here. The second example, where we at? Right here, gets a little bit more complicated because we have these little subscript letters, H2SO4. Let me clean off the board and we'll show you this one. Keeping in mind that every letter, every capital letter, is a new element from the periodic table, H2, capital S, capital O, 4, means that we have 3 elements from the periodic table that are represented here, right? The capital H is hydrogen, capital S is sulfur, and capital O is oxygen. But now these subscripts throw in a new little curve, a new little trick. This 2 only applies to the hydrogen. So instead of having 1 hydrogen, we have 2 there. Sulfur here doesn't have any little number next to it. Remember, if you don't see a little number, then it's automatically a 1. And oxygen has the 4 next to it, and it belongs only to the oxygen, and so we have 4 oxygen atoms. Adding those up across the top, using the power of addition, we have a total of 7 atoms in the formula. Okay? Seems pretty basic, but this is a skill that you've got to have, especially when we get to balancing equations. You got to get to know how to look at a formula and see the individual parts. All right? Let's kick into some more difficult ones. What happens when you have a problem that has parentheses like this? Okay? 6 just isn't challenging enough. Let's take a look at 8. 8 is, it's got parentheses and it's got subscripts. It's getting a little bit crazy. So let's take a look at how we tackle that one. Every capital letter is a new element. And so calcium with a 3 next to it. And here we've got parentheses. So now we're going to start worrying about parentheses. Let me shift the camera a little bit. What do we do when we have capital letters inside of a parenthesis, and then we have another subscript outside of it as well? Let's start with what we know. Capital letters. Calcium is 1 element from the periodic table, phosphorus, and oxygen. My recommendation for students when they tackle one of these problems is to start with what's in the parentheses first. We have 1 phosphorus, and we have 4 oxygens. So inside of the parentheses, there are 5 total atoms. The 2 outside of the parentheses applies to everything that's in here. So those of you that are inclined to use math a lot, use the distributive property here and apply the 2 to both the 1 and the 4 here. Some of us, an easier way to think about it is just, I had 1 phosphorus and 4 oxygen, 5 things inside the parentheses. Now I'm just going to multiply that by 2. Okay? So if I had a total of 5 things in the parentheses, I take 5 and multiply it by 2. That means that I've just doubled everything that I had here for a total of 10. And we can't forget about this, the 3 calcium that are over here. Okay? This 2 does not apply all the way over to calcium. It only applies to what's in the parentheses here. So we'll go ahead and we'll add those 3 in at the very end to give us a total of 13 atoms in that formula. Okay? I want to show you one more because it's a little bit complex the first couple times you do it. All right, let's get this off the board. And again, feel free to pause, feel free to rewind, watch this over again if you need to, okay? Let's do this one here at the top, right here. We're going to take a look at this one, which has copper, and in the parentheses has 1 nitrogen and 3 oxygen, but then it has that subscript off to the side, that little 2 outside the parentheses, okay? So we transfer it to the board. We've got copper, and then we have NO3 with a 2 on the outside. All right, we're looking for capital letters. We see we've got copper, and then we see we have nitrogen and oxygen. So those 3 different types of elements that are in this particular formula. So let's count them up. Where do we start? In the parentheses. Inside the parentheses, we have nitrogen. There's no little number next to it. So remember, it's automatically a 1. Oxygen, there's 3 of them. So I'll add those together. Inside of that parentheses, I have 4 atoms. All right? The little 2 outside the parentheses means that this is going to double everything that's in there. If I have 4 atoms inside, when I double it and multiply by 2, that means I have 8 atoms just inside the parentheses. Remember, this little 2 subscript does not apply to the stuff on the outside of the parentheses on the other side, just to the parentheses that's to the left of it, okay? So at the very end, we do have to add in this 1 copper atom that has been sitting there the whole time. So 8 plus 1 gives us an answer of 9 total atoms, okay? Once this clicks, it's a pretty easy skill, but you've got to know it. You've got to understand it. It's going to come in handy along the way. Okay.